Hey, hi everyone. Very good afternoon. This is Dharmesh Vaya. I'm going to be presenting a talk, a bit of a different area under SRE, and it's called Time for Some Chaos. Anyone heard about this name? Chaos Engineering, anyone? Good. So before that, let me quickly introduce myself. I'm Dharmesh Vaya. I work as a senior enterprise architect at VMware. I am also a Google developer expert into cloud and payments, and I also happen to run the Mumbai Cloud Community chapter. So with that, let's get started with this talk. And yeah, this is what we are going to cover in this talk today. A brief primer around chaos engineering and what does it actually mean. When you say chaos engineering, right, what are the principles for that? What are the tools available? And what are certain hands-on examples that you can do it with it? And some best practices to share and leave it for you at the end. So with that, let's get started for today's session. And let's start with something. Oops. Is there a blooper? Sorry, this was a blooper which we all might have seen somewhere. It's like a Windows blue screen, and we all have come across this, right? So we all know, right? Like when this happens, your machine has gone for a toss, and you might not really have figured out like how to recover back. Now, this is actually your, why I'm bringing up this slide, right? I'm wanting to reinforce the concept of resiliency for you all. Okay, so when I say resiliency or resilience for that matter, resilience is actually your ability to kind of bounce back. Now, I'm not going to read this textbook definition, it's for your reference, but it's your ability to kind of bounce back on cases of any kind of disaster, incidents, and so on. Now, the same applies to cloud platforms as well. And when it comes to cloud platforms, it is, again, the ability of the systems, if they go down, how fast do they come back, how fast do they recover, what is the loss of data that they might have made, and like that is basically without losing their operational principles or operational capabilities. So that's exactly what you mean by resilience when it comes to cloud platforms. Now, let me share some stats with you. Does anyone know what does the average cost of infra failures look like? Now, we all have been using managed services from either GCP or any other cloud platforms. Does anyone know what can be the probable cost around any infra failures? Okay, so it's almost like $100,000 per hour. Okay, and if this you kind of amplify it further, infra failures would lead to critical application failures, and this goes up to almost like 5x this cost, which is more than that, and it's like almost $500K to $1 million per hour. So now that's really a huge cost as such when it comes to any kind of failures, and you don't want this cost to be burning your budgets as such. So what is the solution? So it's the best approach is that like how do you make your apps more resilient? Now that's one of the foundational aspects around site reliability, or if you even talk about site reliability engineering, SRE principles, it's all based on the factors around resiliency and reliability, right? Now, if and I'm talking further around the cloud native applications, right? What are the layers or point of failures that you can think of when it comes to failures? So your app is just that top of that pyramid, and it actually resides on a humongous layer of services, infrastructure, platform. Let's quickly see what are these looking like. So these can be like immediately residing upon something called other application dependencies. It can be your libraries. After that, it can be any cloud native services, something like Istio, Envoy, anything of that sort. So it will then come as the third layer. Then comes your Kubernetes services. So that obviously is your important layer, and which is also a point of failure, I would say. Then comes your platform services, which is where your actual compute, storage, network would actually reside, which is your cloud platforms itself. So it is your entire infrastructure layer. Now, again, just to reinforce now, coming back from that resiliency background, now if I want to say what is chaos engineering. So again, I'm not telling this is the solution, but it's actually a branch or a disciplined approach of experimenting with your systems so that you have ample confidence in your infrastructure with your applications to kind of operate steadily and withstand any sort of turbulent conditions. So it's like as much confidence you're building in your system, and that's what chaos engineering is actually is. You can read more about that in the principles of chaos, but yeah, this is the textbook definition, and I've highlighted 3 words out here. You experiment, you become more confident to handle turbulent conditions, and that's how like experienced pilots also go for, right? How do they handle turbulent conditions or turbulent weather? They gain it by confidence, and the more you are exposed to violent conditions or turbulent conditions, you get more prone to becoming more confident. So okay, chaos does not mean your world goes upside down. Chaos, it's just a term. It's not meant to be an upside down or making your entire infra upside down. Don't just go for a topsy-turvy. Don't test anything out of the box. It's not about testing things carelessly. It's about breaking things with a purpose. If anyone from a testing background or any from a QA background as well, this might be the next field for you when it comes to cloud, right? So if you are kind of breaking things on purpose, but with a objective, with a goal, this is chaos engineering for you, right? Now, if we go from the principles of chaos, right? Now, there are certain phases. Now, see, as I mentioned, it is more of a disciplined approach. Now, in any disciplined approach, it's a scientific methodology that gets applied. And with this kind of methodology, you need to understand what are the phases or how do you kind of bring in or inculcate this discipline. Now, there are certain phases. So in practice, what actually happens with chaos is there are certain phases to this. So when you want to understand what is my expected outcome, so this is the approach that you need to follow. So there are 4 principal phases that need to be followed. First is the steady state, which actually helps you define what is going to be my infra looking like or what is my baseline objective. Then comes the hypothesis. It's as good as any kind of experimentation that you do. Now, hypothesis is establishing your baselines from the fact that, okay, what should my application or infra look like in cases of failure? So how should they behave? That's my hypothesis. Then comes the experiment, and finally comes the verification stage. So these 4 stages, it's as simple as understanding, or any scientific experiment that you do, right? You want to form some basis or some theory to that, and this is exactly the steps that you need to follow. So, and yes, of course, the harder it is to disrupt your steady state, which means that your application will become more resilient and you will gain more confidence. So that's why this last line which I have written, the harder it is to disrupt your steady state, the better will be your application. So form your steady states in a much controlled manner, in a much refined manner, and I'm sure you will have better outcomes from the results of chaos engineering. So let us first understand what is steady state. So as I mentioned earlier, right, it's basically establishing your prerequisites. You need to understand what do I need to test, what kind of failures am I observing with my application, or what is the business objective as such. This can also translate to the related business objectives translated into technical objectives. So this can form your steady state. It can be as simple as establishing what is the bare minimum throughput, latency, CPU, memory utilization, and so on. So everything of this becomes my basis of steady state. Next comes the hypothesis, which is my behavior during failure. So what if a system fails? What if my pod goes down? What if my memory goes full? How does that behave? How does the application bounce back? What is how does the application actually translate back into these scenarios, and how does it gracefully recover? That's actually my basis of the hypothesis. Now it can be into all possibilities. It can be infra, it can be application performance, it can be latency, or it can be as simple as the SLOs and the SLIs by your cloud providers or your service providers. So all these can be the basis of establishing your hypothesis. Now, why am I emphasizing on these 2 facts, steady state and hypothesis? Because again, that's exactly the basis of the third phase, which is experiments. Now, the better variables you have for your experiments, obviously you are going to perform those experiments in a much more refined manner, in a much controlled environment, and your objectives would be met. So again, if I say what are those experiments, these will be derived from your steady state and your hypothesis, but these will then be tied into real world events. What are those catastrophic failures? What kind of failures can come? It can be hardware failures, it can be infra failures. When I say infra, related to software defined failure. So if you miss out some variable namings, or it can be anything as such. A CPU goes for a toss, a memory goes for a toss. Everything of this sort is actually considered under infra failures. When I say hardware, it's actually related to power and the entire network going down and so on. And the last but not least would be application failures. Application failures would be more functional in nature, but yes, they can be considered a part of the experiment itself. It can be a part of the functional test cycles as well. Then finally, obviously, you verify everything. So now you had your steady state, you had your experiments, you had the hypothesis in place. But then what do you do out of all this? Okay, you need some matrix to be established. Who doesn't like matrix, especially if you're talking to any managers, right? They all need matrix. Okay, you are doing chaos engineering. Why are you creating chaos for me? Give me the matrix, give me the results, and tell me like what's going to improve for me. Okay, so need to define those matrix from the steady state. Now this matrix can be as simple, again I'm reiterating the facts, that it can be as simple as what is my threshold going to look like if it is matching from the experiments, or if it is matching from the hypothesis, whether it is going good or not. And in certain cases, how accurate it is from the hypothesis also. In certain cases, you can extrapolate the results as well. For example, in a particular condition, an application is behaving in an X manner, but let's say if the infra is improved 2x or 3x, it might improve better. So if you don't have the right resources or the bandwidth to kind of do a large scale testing, you can extrapolate to a certain extent, and that's pretty much fair in certain cases of infrastructure. Now, to sum this all up, all the 4 phases of chaos engineering, what is the end goal out of this? How does it all tie up or gel together? The fact that the overall reduction in downtime, that is my prime objective when it comes to the outcomes of chaos engineering. So the first one, reduction in downtime, giving me more resiliency. The second one, obviously tied to revenue loss, okay, minimal revenue loss. See, every infra goes down, no system is 99 or 100% accurate. That's why even the cloud providers, you'll see they are either 5 nines or 4 9 accurate, okay, and every system is bound for failure. So how do you kind of reduce that amount of failure and tie it back to financials as well, so that when you kind of present this to your higher management, you kind of talk about numbers as well. So reduced revenue loss. The third one, and the most important one, improving user experience. You all have seen shopping carts which are kind of failing due to some product not available, and you sometimes see a fancy icon over there, some dog or some cat over there, right? It's kind of improving the user experience out there, and it's not just a failure, but a better way of representing your failure. Failures will happen, but then without your end users coming to know that something has gone wrong in the back end, okay, let it get fixed automatically. By that time, I don't want to lose my user. So if you improve your user experience during these failures, okay, I think that will also add to the value of improving the resiliency of your system. And finally, with all this, what I want to do is improving the overall confidence in my system. So if I kind of achieve all this, I know my system is going to perform well in certain objectives or in certain scenarios which are catastrophic in nature. So that's basically going to be the summation of all the 4 phases, which eventually give me better confidence in my systems. Now, there are several platforms. We are into platform-based world, I would say. Okay, and we don't build everything from ground up. So there is something which is readily available for us, and there are certain platforms or tools and frameworks, you can call them. I'll just name a top few over here, and then one of them we'll actually see in a demo. So the first one is called Chaos Mesh. The second one is Chaos Monkey, which is actually something where it actually all started. So a popular streaming service started this whole principle around chaos engineering, and this was the outcome of the whole exercise. So this is a popular one. The third one is Gremlin. Although it has an open source edition, there is also an enterprise edition. It's heavily used in enterprises as well. The fourth one, which we'll also see in the demo, it's called Litmus. And I really like this name, Litmus. It's actually your litmus test, and it really resonates with the scientific experimentation as well. And the last one is called Chaos Blade. These 5 are the most popular ones, and they are heavily used when it comes to anyone trying out chaos engineering. But yes, eventually it's somewhere between these that you will end up using when it comes to the implementation of chaos engineering. So quickly running through Litmus, it's basically a cloud native framework that will have, it's basically open source. You can write your own CRDs into that, which means if you have your templates written, you have your YAMLs, you can just plug them in, and these can behave as scenarios or tests for your chaos engineering principles. Quickly telling you what exactly is the control plane looking like. So you need not go deep down into this, but yes, if you just have to understand what are the basic components. So there is something called a control plane, and there is something called an execution plane. Your control plane is basically responsible for all the authentication, managing of the data, and the execution plane is basically where all your tests would actually run. So this is where all the testing would happen, and then it will spit out results and all. Okay, so from an experiment perspective, I'm not going to run through this in depth, okay? But yes, if you just understand from an experiment perspective, you need a lot of parameters. You need to define a lot of scope, variables, and then based on that, so again, this is a part of that same principles, which is hypothesis, experiments, and then the verification stage. So what do you need to conduct an experiment? It's basically any specifications that you need to test out. That is something that will come over here. Now, let's pick 3 scenarios. So the first one being around any disaster which is related to compute failure. So what happens when a pod goes down? So how do you kind of actually test that? So there are experiments which are readily available in Chaos Hub from Litmus Chaos, and it's basically testing your resiliency from the application side of things or from the infra side of things, that what will happen in case of pod failure. So how does the application bounce back? If a pod goes down, how does it kind of come back, and so on. So it is going to simulate that for you and then give you an outcome saying that, okay, hey, your pod went down at this time, and by this time the pod also went up. We kind of did an auto scaling or did an auto regeneration of the pod and so on. Again, there is a whole workflow for this. You can kind of really see that which are my targeted pods, which pods do I need to run my test on, and where do I run these tests. So it can be within the environment or outside the environment. So when I say within and outside, it means that you want to run the test as an outsider or within the same set of cluster or same set of pods, you can do that. So a similar scenario, which is in case of a network loss. Now, what would happen in case your application actually or your pod actually faces a network loss? What would happen in that case? So it can be, things can go for a toss, right? Traffic flows can be disrupted. Your services will be disrupted. So what is the objective, or what is the outcome that would happen in this case? So here, it's basically testing the resiliency from a networking perspective. It's not going to touch the pod. Your pod can be, the compute can be like heavily overloaded. Even then, the network can go off. Depends. There can be multiple scenarios. So again, there's a huge workflow for that, and these are all readily available. You don't need to write a single line of code for this. Experiments are available. Pick them and run them. Okay, and finally, we'll pick one scenario around storage, which is what if your pods or the ephemeral storage for your pod, it can be either ephemeral or the persistent, either of them. What if either of them kind of gets filled? So this one actually simulates a pod fill, or rather a storage fill or a disk fill, and then it will simulate like, okay, what happened now? Is your application able to handle this failure or not? And then it will take corrective measures by either like scaling or throwing up appropriate error messages and so on. So here it's basically filling up the storage and then telling you that, okay, hey, your pod is not able to respond because your storage went full. Okay, and yeah, we'll quickly see a demo of the Litmus platform. Can I have switch over to the deck, please? Okay, so this is how the Litmus framework kind of, or the platform looks like. Sorry. Okay, this is what the Litmus platform looks like. I have, this is the GCP console itself. I have created a cluster specifically for Litmus. And over here, you can see that there are different scenarios available. So these scenarios are basically either from a pod delete perspective or a pod disk fill perspective. Here, it's just a UI-based dashboard. And let me quickly show you a recorded demo. So here is a login screen, and if you see from here, okay, so it has all kinds of facilities like user management and the access control and all. So what you need to do is basically create a ready-made one. Okay, so this part is interesting where you can see that the entire flow of your experiment is kind of given over here. So here you can kind of rearrange whether first you want to do a pod delete, whether you want to do a network test, and so on. So this part is more of a graphical interface, and in the end you basically, I mean, it does take a while. It takes almost 15-20 minutes to even simulate a pod delete. But yes, after this, you will come to know that, yeah, the scenarios, whether they have passed or failed, you kind of see that back into the graphical state itself. So here you will come to know whether the pod delete worked fine, what was the outcome. You will get a tabulated result, and plus you can send out notifications as well. So this is a very high level introduction around the platform itself, and you can try it out by yourself as well. So there is Litmus Chaos, and you can just create a cluster and use that. Can I move back to my slides, please? Okay, so ending this with best practices, I'm sure like this compressed 25 minutes, you just got a high level overview of what chaos engineering means and where you can apply them. Just a few quick pointers or takeaways for you when it comes to best practices. So the first and foremost thing, always focus on your infrastructure. The more you kind of dig into the different vulnerabilities or point of failures from your infra, you're going to design better scenarios, and your chaos engineering would improve, eventually improving the confidence in your system. The second, tie all your hypotheses as much as possible to your SLIs and SLOs provided by your cloud provider or provided by any infra provider, because that is going to be a benchmark that you're going to use forever. The third one, and an important one, the more you practice, I always take this example of a pilot or a flight commander. The more they fly, the better it is their confidence when it comes to flying aircrafts. The same applies for driving as well, right? The more you drive, the better is your confidence. So try to understand the impact of chaos from, by practicing more in different scenarios, different environments, and I'm sure you will end up with better scenarios of testing. Third one, continuous chaos. Now this is, or the fourth one rather, it's a new term, just as CI/CD is happening. The world is also digressing into continuous chaos, which means that you can take chaos into production as well. And the better, you can have it more in a controlled environment. So if you can do that, well and good. If not, that's also okay. So that's why the fifth point is mentioned, which is limiting collateral damage. When you do it in production, ensure that your primary services are not under chaos, or else you will end up in chaos. So ensure that you have minimal collateral damage. fine-tune your scenarios, test something which is not really very active or very hot in the usage patterns, and that should actually solve a lot of worry for you, and you can have a broad confidence in the entire system. So with that, I would just end up on one note. Like, we all say that, okay, Kubernetes is the answer to my scaling problems. That's that's not the case. We all know that. Okay. Similarly, chaos engineering is also not the answer to resiliency. It's a more of a disciplined approach when it comes to building confidence in your systems and making your systems more reliable and more resilient to any kind of turbulent conditions. So again, don't take this as the final word in saying that, okay, for anything to improve my resiliency, let's do chaos engineering. Check your systems, understand them, understand the business use cases, and then go for these kind of tools and frameworks. So yeah, that's all from my side. Thank you so much. This is Dharmesh Vaya. Thank you.